Hi everyone, I'm Gutwin, and in this video I'm going to tell you about a project that we did that looks at command shortcuts for mobile devices. Specifically, at what happens when different apps use the same shortcut mechanism for different commands. We asked the questions, do the different mappings interfere with one another, and is it harder to learn new mappings when you've already learned one? And when we tested our system with 3 different command mappings, we found that there was no interference. The second and third mappings were actually learned faster than the first, and there was no detrimental effect on performance. This provides evidence that general-purpose shortcut mechanisms can be successfully used with mobile devices. Okay, here's what I'll talk about in the video. I'll start with the general problem of why we would want to use shortcuts in mobile devices, then introduce the prototype we built to provide chording shortcut buttons on a phone case, and then describe the study we did to look at what happens when we overload the shortcut buttons with 3 different mappings. To begin with, our motivation for looking at shortcuts is a general problem with mobile interfaces. Because screen space is limited, the user ends up doing a lot of visual navigation through menus and toolbars to get to the commands that they want, even for their most frequently used actions. In desktop systems, interfaces try to support expertise by adding shortcuts, like keyboard shortcuts, that the user can just remember rather than having to navigate to. But in mobiles, there's no keyboard, so researchers have looked at several other ways to provide shortcuts, from marking menus to bezel swipes to multi-touch menus, or the solution that we chose for our prototype, external buttons. We built the phone chords prototype to explore issues around having a generic set of shortcuts that can be used by any application. We attached 3 push buttons to a 3D printed phone case and wired them up to the circuit boards from Bluetooth flick buttons that have an API for sending Android events. To use the buttons, you hold the phone in your non-dominant hand and your first, second, and third fingers rest on the 3 buttons. Here's what it looks like in use in our training application. You push the buttons in various chorded combinations, 3 that use 1 finger, 2 that use 2 fingers, and 1 that uses 3 fingers, giving us 7 states to work with. In the video, you can see the buttons being pushed on the right side of the case to select different colors. And this is a much faster way to make selections than in the visual navigation through menus that we saw earlier. But it does raise the question of what happens when the shortcut buttons get used in different apps for completely different sets of commands. And this was the subject of our user study. We developed 3 very simple apps that have different mappings from the 7 chords that we can produce with the buttons to 7 different commands for each app. In the drawing app, the buttons chose colors. In the text edit app, the buttons chose formatting commands, and in the launcher, the buttons corresponded to a hot list of commonly used tools. So here's an example of what the drawing app looked like. And we combined regular touch actions on the screen, here the users using their finger to draw a shape, with commands to select different colors, and these were expressed using the shortcut buttons. And here's the text edit app. And again, we combine standard touch actions. Here the user swipes to select text with formatting commands that are chosen by the chorded button presses. So our study's main question was what would happen when the generic shortcut chords were mapped to the 3 different command sets in our 3 applications. We had participants learn all 3 mappings in different orders over 10 blocks of trials, and we measured their learning curves and performance. Here's what we found for the time it took for people to select the correct command in each block with each app. And you can see that there isn't much difference between the apps. all of them follow about the same learning curve and all come out to about 2 seconds to make a selection once people have gained experience. But what was really interesting was when we looked at the differences between the first mapping that people learned compared to the second and third mappings. In this chart, the purple line is the first mapping, and that means that the second and third mappings were actually significantly faster at all points along the learning curve. Now, it is likely that people were getting better at the system overall, and that could explain some of this difference. But the results here show that there's definitely no problem with the first mapping causing interference for learning new mappings. And the results for the number of mistakes that people made before they selected the correct command were similar to these, although the differences were less extreme. There are a lot more results in the paper, but to summarize this brief overview, we had thought that learning multiple mappings would cause interference problems, with new mappings being harder to learn, but that was not the case. Later mappings were learned faster, and there was no difference in accuracy. This means that one of the potential roadblocks for using general-purpose shortcuts in mobiles, that people won't be able to deal with different apps mapping the shortcuts to different commands, isn't likely to be a problem. And this is good news for designers who want to do a better job of supporting expert users, users who want to be able to select commonly used commands in mobile environments without having to endlessly navigate through menus and toolbars. So if you're interested in more results, please see the paper in the GI proceedings or contact any one of us to discuss things further. And thanks very much for watching.